Hello students, today we will learn how to find range of a function. It's important to know the domain first before finding the range. Domain is the set of all possible x values, whereas range is the set of all possible y values. Domain is our input value and it is independent. Range is the output value and it is dependent. First element of ordered pair is the domain. Range is the second element of ordered pair. In this example, 2 is domain and -3 is the range. Let's understand this concept with the help of an example. Suppose we have a function f of x equals x square, or we can write it as y equals x square. Here, this f of x and y means the same thing. Now, we have to find domain and range of this given function. As x is our input value, so we can choose any real number for value of x, and by plugging these values one by one in the given function, we get value of y, or our output. Okay, let's start. Put x is equals to 0 in the given function. We have y equals 0 square, that is 0. For x is equals to 1, it will be 1 square, that is 1. When x is 2, our value for y will be square of 2, that is 4. When x is 3, we get 3 square, that is 9. When x is -1, it will be -1 square, that is 1. Because the power is even, that's why the negative will turn to positive. When x is -2, our answer for y will be positive 4. For x equals -3, we get 9. As x values make domain, and these are all real numbers, so our domain will be set of all real numbers, or in interval form we can write it as -infinity to infinity. For range, we focus on y values. As there is no negative number, so range will be positive, and the minimum value for range is 0. So range will start from 0 and all positive numbers are included. Now the function is x plus 7. It is a linear function, and clearly we can see that for each value of x there is an answer for y. So its domain will be set of all reals. We can also check this by drawing this table. Put x is equals to 0 in this given function, that is x plus 7. It will be 0 plus 7, that is 7. At x equals to 1, the answer for y is 8. At x equals to 2, y value is 9. At x equals to 3, y is 10. At x equals -1, y is positive 6. When x is -2, the output is positive 5. For domain, we check x values. So all real numbers are included in the domain. And for y, look at y values. The numbers are increasing towards right and decreasing towards left. It means all real numbers are included in the range. This is a polynomial function, therefore its domain is the set of all real numbers. The reason is, for every real value of x, we get an answer for y. But for range, this table will be helpful. Put x equals to 0 in this given function, that is 2x squared plus 1. This is the given function. We put x is equals to 0 in this function. The value of y is 2 into 0. 0, 0 plus 1 is 1. When x is 0, value of y is 1. When x is 1, it will becomes 2 into 1 square plus 1. 2 into 1 is 2, 2 plus 1 is 3. At x equals to 2, we have 2 into 2 square plus 1. 2 square is 4, 4 into 2 is 8, 8 plus 1 is 9. For x equals to 3, the value of y is 2 into 3 square plus 1. 3 square is 9, 9 into 2 is 18, 18 plus 1 is 19. At x equals negative 1, we have 2 into negative 1 whole square plus 1, that is positive 3. At x equals negative 2, we have y equals 2 into negative 2 whole square plus 1, and the answer is 9. X values makes domain. So domain is the set of all real numbers. For range, we focus on y values as there are no negatives in y values. So our range is positive and it starts from 1. Here is an alternate way for finding the range of the same function. As we know that the value of this x square is always greater than or equals to 0, even if the number is negative. Due to even power, all negative numbers will turn to positive. Now in the question, it's 2x square, so we multiplied both sides with 2x square. 2 into 0 is 0. The function is 2x square plus 1. Add positive 1 to both sides of this inequality. It means that our range should be greater than or equals to 1. Means all the numbers greater than 1 and 1 are included. This is the same range that we have found from the table. This function consists of square root, and we know that there should be no negatives inside square root. It means that this x minus 5 should greater than equals to 0. From here, we can easily find out the value of x. That is, x should greater than equals to positive 5. So this is the restriction to our domain. Means x values should greater than or equals to 5. We cannot include numbers less than 5 in our domain, because when we do so, we get imaginary number. Look, at x is equals to 4, what we get? Negative 1, which is an imaginary number. It means our domain is 5 to positive infinity. Another way for writing the domain is this one, x belongs to real numbers such that x should greater than equals to 5. For range, put this first value of x in the given function, that is 2 into under root 5 minus 5. 5 minus 5 is 0. Square root of 0 is 0. 2 multiplied by 0, we get 0. So our range starts from 0 and all positive numbers are included. Inside the function, we have absolute of x minus 2. And we know that the absolute value function is defined for every real number and there are no restrictions. Therefore, domain will be set of all real numbers. Now, let's find range. The absolute value is always greater than or equals to 0. That is, absolute of x minus 2 is greater than equals to 0. Now, in the given function, there is negative 3. So, we subtract negative 3 from both sides. Mod of x minus 2, negative 3 should greater than equals to negative 3. Means negative 3 and all the numbers greater than negative 3 are included in our range. The function is 1 plus sine x. We should know the domain and range of this sine x function. Since sine function is defined for all real numbers, means whatever the value of x, there is an answer for y. So, domain will be set of all real numbers. For range, we know that range of sine function lies between negative 1 to 1. Both this negative 1 and 1 are also included. For example, at x is equals to 90 degrees, y becomes sine 90 and the value for sine 90 is 1. When x is negative 90 degrees, y value is negative 1. When x is 0 degrees, the answer for y is 0. It means whatever the value of x, the answer lies between negative 1 and 1. Also, negative 1 and 1 are included in our answer. It means the range of sine function is this one. But the function is 1 plus sine x. For finding the range of this 1 plus sine x function, simply add positive 1 to the range of sine x function. It becomes 1 plus 1, that is 2. And at this side, after adding positive 1, we get 0. So, range of the given function will be 0 to 2. When square root is given in the function, there is a restriction that the number inside the square root shouldn't be negative. It means that this x minus 2 should greater than equals to 0, means this is a positive number. From here, find value of x, that is positive 2. So, our domain values should be greater than or equals to 2. 6, so on. Now, let's find range. The given function is y equals 3 plus under root x minus 2. Put x equals to 2 in this given function. we have 3 as y value. So our range starts from 3 and all positive numbers are included. The function involves e power x, which is defined for all real numbers. Therefore, the domain for this function will be set of all reals. Now for range, as we know that this e power x is always greater than 0. Here this e is Euler's number and its value is 2.7. Now we check for different values of x. This is the table for e power x values. When x is 0, it becomes e power 0, and when the power of any number is 0, it is equals to 1. When x is 1, we have e power x, that is e power 1. The value for e is 2. It will be 2.7 power 1 is 2.7. For x equals negative 1, to make this power positive, take it in the denominator, it will be e power 1. Now it becomes 1 over 2.7. 1 divided by 2.7 is 0.4. So it means the values of e power x is greater than 0 means positive values and greater than 0. Now in the given function, it's 3 into e power x. So we multiplied 3 both sides. It becomes 3 into e power x, and at this side it will be 3 multiplied by 0, that is 0. And then divide both sides by 7. Again, this is greater than 0. So clearly we can see that values of y are greater than 0 and are positive. So range will be 0 to positive. At 0 is not included, so we use open brackets. The given question is in the form of fraction, and we know that denominator shouldn't be 0, otherwise the function will become undefined. So this x plus 4 should not equals to 0, means that this x is not equals to negative 4. So our domain will be set of all real numbers excluding this negative 4. Now let's find range. The function is x squared negative 16 over x plus 4. By simplifying the numerator, we have x plus 4 into x minus 4 over x plus 4. This x plus 4 is cancelled with this one, and we are left with x negative 4. Now, at x equals negative 4, our value becomes negative 4 equals negative 8. It means y should not equals to negative 8, because at negative 4 the value of y is negative 8, but negative 4 is not included. It means we will subtract this negative 4 from the range. It is there is no restriction in this question. So a domain is the set of all real numbers. Now we find range. As we know that the square of any number is always greater than equals to 0, that is this x minus 1 whole square is always greater than or equals to 0. In the question, there is positive 1 added to this x minus 1 whole square. So add positive 1 to both sides. We get x minus 1 whole square plus 1 is greater than equals to positive 1. So this gives the range. That range should be greater than equals to positive 1. So our answer is 1 to positive infinity. Denominator can't be 0. So x minus 1 should not equals to 0. Value of x should not equals to positive 1. It means domain will be set of all real numbers excluding this 1. Now for range we solve the given function y equals 1 over x minus 1. By cross multiplying this x minus 1, we have y into x minus 1 equals to 1. And then x minus 1 equals 1 over y. Now we are finding the range. So this y should not equals to 0. It means our range will be set of all real numbers excluding 0. Again, the question is in the form of fraction. So this x plus 3 should not equals to 0. X should not equals to negative 3. So domain will be real numbers excluding negative 3. Now for range, we solve for x. By cross multiplying this x plus 3, we have y into x plus 3 equals x minus 2. Multiplying y inside, we have xy plus 3y equals x minus 2. Xy plus 3y negative x equals negative 2. X is common from these two terms. So we have x into y minus 1 equals negative 2, negative 3y. X equals negative 2, negative 3y over y minus 1. Clearly, this y shouldn't equals to positive 1. It means range will be all reals excluding 1. This x minus 3 should not equals to 0. So x shouldn't equals to positive 3. And the domain will be set of all real numbers excluding this 3. For range, we solve this given function by factorizing the numerator. Here we use midterm breaking. X squared negative 3x plus 2x negative 6 whole divided by x minus 3. X is common from the first pair, so we are left with x minus 3 plus 2 is common. It's x minus 3. Again, x minus 3 is common into x plus 2 divided by x minus 3. This x minus 3 will cut with the x minus 3 present in the numerator, and value of y will be x plus 2. As this 3 is not included in the domain, so by putting this value of x, that is 3, in this, we get y equals to 5. As this 3 is not included, it means that this 5 is also not included in range. So range will be all real numbers excluding this 5. Here is a quick reference chart for domain and range of some functions. Hope this video will be helpful for you. Thank you for watching.